Okay, let me just show you a little bit about playing around on this normal distribution calculator site. So first of all, every normal distribution has an address, so a thing that uniquely identifies it, and that's the mean and the standard deviation. So for this app, all you need to do is put in the mean and standard deviation of a normal distribution. In the discussion section, we'll look at IQ test scores. So let me use that. IQ test scores, at least traditionally, tended to follow a distribution with an average of 100, mean of 100, and a standard deviation of 15. So here we can see how that played out. 100 is the most common score, in between 85 and 115. So that's a standard deviation in each direction. We have the big majority of the data. It's about 2/3 of the data, 68%. And then we can move out here. Most of the data is within two standard deviations of the mean. So we can specifically look, for example, on how rare is it to be classified as gifted. And that's often seen as above 130 or 135, depending on how it's used. So let's say we want to do above 130. You can see that in all the IQ test scores, this would be a distribution of IQ test scores, only the ones up here have either a score of 130 or even higher. And we can see that's very rare. This is the probability or the proportion of the scores that are above that, which is 0.0228. In other words, between 2 and 3%, only between 2 and 3% of people in US society would have IQ scores above 130. And if we did, I forget what Einstein's was, let's say something like 170. It'll say that it's so rare that 0%. Now that's not really true. It's actually 0.00001. And if we wanted to take a closer look at that, we could use our Google Sheets. Let me do that real quick. Okay, so the formula that we would type in is basically the opposite of what we were doing for the focus task. Here, we know a specific point, and we want to see what portion of the normal distribution is either below or above that point. So norm.dist, and then if I put a parentheses, it gives me all this helpful information that I strongly recommend you use as you're using functions and formulas. Give you a little background on how to do it, but also examples and definitions. So X here is probably the more confusing part. So the mean and standard deviation, let me go ahead and put them in first. The mean of the IQ distribution would be 100 with a standard deviation of 15. And this cumulative part, we're just going to put true. Cumulative just means, do you want everything below it as well as the individual point you're at? And in this case, we do. We want that entire region. Maybe the trickiest thing there is the X value, what that actually is. Well, in this case, we're putting in 170 because that was Einstein's score. And if I press enter, notice I get a really high number, which is a little confusing because on that sheet we just looked at, it was 0. It was a very, very small number. These scores will always range between 0 and 1. So it was basically about as small as it could be on the other site. And here it's about as close to 1 as you can get. So what's going on? Well, this norm dist function always gives you the area to the left. In other words, this is what portion of the US population would have IQ scores less than 100. Less than 170, which is what Einstein's score was. So if we wanted the ones that were even above Einstein, so how rare is it to be above 170? And by the way, I don't think Einstein ever took an IQ test. I just Googled it, and they said maybe it was only like 160 or so. But the point is here, if we wanted to know how rare it is to get an IQ above 170, we would want the opposite of this. So that other website we were looking at could nicely just give us the area to the right, that tiny little tail to the right, whereas this is giving us the entire opposite of what we want. So all we have to do in our formula then is go 1 minus this amount, and this would give us the area to the right of that IQ score of 170. So in this case, if we would convert this to a percent, we'd shift over to 2 decimal points, or we could even just go to Format, Number, and hit percent. It'd be 0%. What it really is 0.0000153%. That's just how rare it is, and it's so low that that rounds to 0. So this formula could be useful. And if we did want the portion that were less than a certain amount, we wouldn't even have to put this 1 minus. That's only if we want the right tail of a normal distribution, something that's above a certain score. Okay, and real quickly, you can use this calculator for a couple different situations too. So we could also say, how rare is it to get below an IQ score of, say, 60? And press enter. You can see it's a pretty small portion of the people who take that test. It would be 0.0038. If we convert that to a percent, it'd be 0.38%, but it'd be less than 1%. If people would have an IQ test score that low. Or we could say between. So let's say we wanted to know what portion of people had an IQ test score between a 100 and a 110. We press enter. So we're just looking at that chunk of the distribution, and it looks like about a fourth of the people, or about a little under 25% of people, would have an IQ test score within that range. Now, before I get too far, make sure you do the discuss section, because there are some major issues with IQ test scores. I'm using this as an example to illustrate just some of the calculations, but there's some major ethical issues with IQ test scores that you'll really want to pay attention to in the discussion section. So in the Explore section, we look at what's called the standard normal distribution. And all that is, it's a very specific normal distribution with a mean of 0 and a standard deviation of 1. So this gives us the distribution of what we call z-scores, or standardized normal scores. And if you wanted to see how rare it is to get a z-score above, say, 1.5, you could see that about 6–7% of the distribution would be above a z-score of 1.5. Or maybe we want to look at above a z-score of -2. This would be the -2, and this would be the entire portion above, which is most of the distribution, right? Almost 98% of the distribution. So this particular normal distribution is so famous and so nice to use, to be honest, that we give it a name, the standard normal curve, and these z-scores can be used.